it is a concatenation. It's sort of the what happens when you append. So I have unbalanced parentheses somewhere. It's slime is getting annoyed, so I'm actually not going to write this. So let's see. Let's define this function. I might not keep it. Free group element G and so what this will do is within the free group it'll it basically just does a concatenation. The only thing we need to make sure is that the elements are okay, they're valid. So we're gonna say valid P element, and we need to check that let's see, the size or the num elements is the free group num elements of our group G. Did I spell that right? Elements. Yep. Let me just compile this. So the number of elements, and all we need to do is check that if they're within negative num elements and positive num elements, then it's valid. So first we want to assert that every one of those elements is valid. Valid P elements. Let's put a little nice error message. Elements. P provided free group I should say and secure P E So yeah, this is just a sanity check. We're just checking that every element that's provided to this free group element function is an actual free group element. Otherwise, let's just return back elements. Let's start with that. So if we do this and we go down to here, and we do, well, let's make a free group. Let's def parameter free, if I can type, free make instance with num elements. Let's do a free group of 3 like our example. So if I do free group element of free with, let's say, let's do our example 2, 3, -1, then we just get back our list containing 2, 3, -1. This data structure isn't super, just a plain old list isn't a super good one, because we can't really append to it very well, and so on. If we want to do kind of what we did here, our x times -1, we can't really do that without traversing the entire free group element. So it'd be nice if we can append to the end of the list expediently, which we'll modify that. The second thing is that free group element does not take care of composite elements. So the result of free group element is itself a composite element. So we need to be able to take care of that. In fact, let's write these things down. We need to recognize composite elements. Almost more importantly, we need to recognize the ability to invert elements and so on. So basically we need to implement our group protocol. So let's do that. So def method group identity. Oops, it wasn't group identity, it's identity identity element of our group, which is a free group. Simple. Our identity element is always just 0. It might be a good idea to put that into a list. Well, hold off on that for now. Def method compose, if our group is a free group, and we have two elements A, B. I want to validate here, so to do validate, I'm going to abstract out this validation function a little later, and I'm going to put it in here. But anyway, to compose two elements of a free group, we append them in some way. So we can do free group element A and B. If A and B if either of them are lists, then we need to make sure to append them. So what I'm actually going to do is do a mapcan here. Mapcan, I'll call it process elements. So mapcan is kind of like mapcar, that mapcan is like mapcar, but it takes elements that are lists and appends them. It maps and then concatenates. It's like map append or mapend or whatever. And by the way, Joey, types would not be helpful here to do validation. They'd be validating, if that's what you're referring to. Validation would work at the type level in the sense that we'd be able to tell that these things are integers. Namely, we could eliminate this check right here. However, we would not be able to do this check with any standard type system. So where was I? So we're processing elements, but what does process mean? Process E means if list P our element, then we just do we want to process that list itself, but we're just going to actually return it. Otherwise, we return a list of E. So if we do now our free group element, but let's suppose we nest this and said free group element of our free group with, I don't know, 1, 2, and we did this. You get an error. Oh yeah, of course you do. Let's change this flet to labels. So when we actually validate, we're running across something that is invalid, and we need to say or. Let's do cond. Type case. Type case on E. And then if it's a list, then we need to ensure that every valid P of E. If it's an integer, then we need to do this check right here. Otherwise, it's not, so we just return null. So let's delete this. So let's try it again. Good. So the one thing to note here is that we have our 2 and 3, which show up here as 2 and 3. And then our free group element here will create a new free group element within this list, but it automatically gets embedded in here. And then -1 shows up at the end. So Yeah, pretty simple. And then our compose function just takes any two things and composes them. So now the last one is inverse. Def method inverse. We have our free group, and then G, and then we have an element A. Inversion is kind of tricky. So, like I said, in inverse, if we have some element, which I'm going to use capital X now, and we want to, and it equals something, we want to provide an inverse, which I'm calling x prime, such that x times x prime equals our identity element 0. Likewise, if we do x prime times x, we get our identity element again. So if we kind of think, let's use our letters again instead of the numbers, just for simplicity. If we have A, B, C, just as our x, then the question is kind of like a little puzzle. What is x prime? So basically, we have ABC times something, 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 which equals 0. Well, if we have something, something here, we need to kind of annihilate each element in succession. So the first element within this question marks must annihilate the C. Once that C is annihilated, it disappears. Next, we must annihilate this B. Well, then the next element must be B's inverse. Then we must annihilate this A, and that must be A's inverse. So what we have is C inverse. That's going to annihilate the C. B inverse. That's going to annihilate the B. A inverse, which is going to annihilate A. Likewise here, if we have, now that we know that CBA is C prime, B prime, A prime, is an inverse, we need to check that it works in the other direction. Well, it does. The A prime and A annihilate, B prime and B annihilate, and C prime and C annihilate. So it works. I don't really like using the... I agree to do this in principle, but when it's just scratch work and if it doesn't get committed, then I'm not usually concerned. Also, sometimes my editor gets a little bit finicky over the quotes, but whatever, I'll do it. But it's definitely not going to be committed. So the general rule here for inverting these things is to take the whatever group element we have and reversing it and inverting each element in turn. So what we'll do is invert each element, then reverse that inversion. This will get kind of tricky because we are now working with we're kind of working with two distinct data types, and we haven't really made that clear. We're working with integers as one possible representation, and then we're also working with lists as another possible representation. We haven't really made that clear anywhere up here except in this type case right here. I'm going to try to make that a little clearer later, but it's just one thing to keep in mind. So we've determined right here that the inverse is C prime, B prime, and A prime. So inverting, like I said, we need to reverse the elements and invert it. But let's do a type case. In fact, I'll do an E-type case. Now, I know that it might be preferable to some Lisp programmers to specialize on A. I might refactor that later, but then I have to make sure that I specialize on A elsewhere if necessary. So I'm going to just start by doing a type discrimination within the method itself, and then I'll consider specializing on A later. So if it's an integer, then it's just the negation of the integer. If it's a list, then we need to do the more complicated work. So let's first let reversed be the reversal of A. once we've regrouped, once